Hi, I'm Yu Chao Chen.
I'm Zhong Yuo.
I'm Zhiting Chen, and we are
Team A!
Woo! Okay, and now we're recording our lab demo video of lab 8. And first, take a look at our convertible 5-volt design. And this is our finite state machine diagram. We have three different stages, which is idle, header, and payload. So in our idle stage, we wait for FF header to show up, which means the start point of our whole packet. So if this FF header show up, we'll transfer it into our header stage and wait for our payload header, which is 00 to show up. And when it show up, we will transfer our stage into payload stage and start to store the real uh, data into our FIFO. And when the header is not uh, when our header is not 00 or FF, it means that it is the end of the whole packet. So now our stage will change back into idle stage and start looking for the next cycle. And also our 504 full signal will be triggered up and change our 504 mode into our processor mode so that our CPU and GPU can use the data we just loaded before in our data memory. And yes, that is.
And we're going to talk about instruction memory initializations. And for the first part is our pointer initializations. For memory 0 to memory 3, we set up memory pointers R1 to R4 for the packet payloads. Uh, from top to the bottom is matrix A, B, C, and our result D. And the next one for memory 4 to memory 6 and our memory 10 is our tensor load and our hardware accelerations, which is our tensor core in our code. We load the 60-bit network payloads into a 3-vector register to store and then triggers the hardware accelerator to compute, fuse, multiply, add. And the final part, the last part is our trigger and packet release. We use it to unlock the FIFO and transmit the packet back to the network to use.
Okay, so like in few days ago, 3 days ago, when we were making this FA report, and we just figured out that when we are making the file and it just have the arrow and produce, we use too many slides, and so in these 2 days, we just trying to fix our Verilog code, and what we're gonna do is to fix our tensor unit. So now we just pipelined the tensor unit and yeah into make the whole system is like six or seven stage, and it is the correct simulation result, and now it is our pipelined tensor unit version of the result. And as you can see, the result is correct. And when we use this code to make the file, this time it yeah finally uh, working correctly. And so now we can test our code on NetFPGA.
Okay. So after our local simulation, we try to load our design on the NetFPGA board I choose. And we also wrote a Python script to uh, to send the test packet. So first we load our bit file like this, and then this is this test tensor.py is the Python script written by us that can send multiple packet packet at once. So we run this script and give it a second.
Yeah.
Give it a second. Yeah, he's working. Okay, okay. And next we can next load our um, test memory. It is what we're reading is a test register we added at the end of our pipeline with which read our output packet. So um, so so that we can see the address 9, address 10, address um, sorry, the address 8 is like this. This is our test data, and here it is our A because we are executing A plus B, A times B and plus C. So this is our first data, and this is our second data here, and this is our third data here. And unfortunately, our result didn't show up correctly, so we're still working on this problem um, to solve it. And yes, and maybe we'll go to tomorrow TA office hour to ask for some solution or opinion, and that's it. Thank you.
Thank you.
Thank you.
Ooh.